Let's talk about something we use every single day, often without even thinking about it. Measurement. It's this invisible framework that literally holds our modern world together. It's the silent language that science, technology, and pretty much all of global trade relies on. So we're going to go on a quick journey from total, confusing chaos to the beautiful simplicity of a universal system.
All right, so to really get it, let's start with the problem. What actually happens when everyone is speaking a different measurement language? The short answer? It's a complete and total mess. I mean, have you ever tried this? You're trying to build a bookshelf, right? The instructions are in inches, all your tools are in centimeters, and the bolts, well, who knows what unit they're sized in. The result is always the same: confusion, a whole lot of frustration, and if you're lucky, a very, very wobbly bookshelf. Now that is a perfect picture of the kind of chaos that happens without a standard system. And look, this isn't just about wobbly furniture. In the worlds of science and global trade, this kind of chaos leads to seriously confusing data, results you just can't trust, and some incredibly expensive mistakes. I mean, think about it. How can a team of scientists in Japan even begin to compare their findings with a team in Brazil if they aren't measuring things the same way? The simple answer is they can't. It's just impossible.
But luckily, there's an incredibly elegant solution to this global mess. It's a system that was specifically designed to bring order to all that chaos: the International System of Units, or as most of us just call it, the SI system.
So the SI system is basically the world's agreed-upon language for measurement. It's the standard that lets an engineer in Germany, a doctor in South Africa, and a physicist in Canada all talk to each other and share their work with perfect crystal clarity.
So what's the secret sauce? What makes this system so powerful? Well, first off, it's universal. It's also incredibly precise and consistent. But the real magic, the part that makes it so easy, is that it's all based on powers of 10. That means no more dealing with weird fractions or remembering bizarre conversion numbers. It just works.
Okay, so how does it all work? Well, believe it or not, the entire system is built on a foundation of just 7 base units. That's it, 7. These are the fundamental building blocks for literally everything we could possibly want to measure.
And here they are, the magnificent 7. You've got meters for length, kilograms for mass, seconds for time, Kelvin for temperature, and so on. Every other unit you can possibly imagine, things like speed, force, energy, is just some combination of these 7. They really are the alphabet of measurement.
Let's just pick one: the meter. It's our base unit for length and distance. And here's a cool fact. Originally, it was defined as 1/10,000,000th of the distance from the Earth's equator all the way to the North Pole. Now, today's definition is way, way more precise, but its whole purpose is still exactly the same.
And then you have the kilogram. This is our standard for mass. And if you want to get a really good feel for it, just picture a 1-liter bottle of water in your hand. That's pretty much 1 kilogram. It's a super simple, tangible way to understand one of these core building blocks.
Okay, so 7 base units are great, but how in the world do we use them to measure something as tiny as an atom or as huge as the distance to another galaxy? This is where the true genius of the SI system really shines. It's all about prefixes. These prefixes are really just simple multipliers based on the power of 10. So kilo just means 1,000, and milli means 1,000th. By just slapping one of these prefixes onto a base unit, we can instantly scale our measurements to be incredibly large or incredibly small. It's that simple. And because it's all based on powers of 10, converting between units is an absolute breeze. Say you want to convert 3 kilometers into meters. You just multiply by 1,000. Boom, 3,000 meters. That's it. It's simple, it's logical, and it's incredibly efficient.
And this right here is a perfect illustration of the system's power. We use the exact same base unit, the meter, to talk about the massive distance between 2 cities in kilometers and the tiny thickness of a credit card in millimeters. It is one single elegant system that covers every scale you can possibly imagine.
So, let's bring it all home. Why is having this one shared system so profoundly important? What's the real-world impact of all this?
Well, it ensures that science can actually operate as a global collaborative effort. It means experiments are accurate and results can be easily compared no matter where in the world they come from. It cuts down on errors and creates a universal understanding that pushes all of human knowledge forward, together.
And hey, if you take one practical tip away from this whole explainer, let it be this simple but totally crucial rule. For clarity, it's always the number, then a space, then the unit symbol. So not 5 meters, but 5 m.
It's a tiny detail, but it reinforces that universal clarity that makes the whole system work.
Ultimately, the SI system isn't just a set of rules, right? It's the language of discovery. It's the very foundation for how we understand our universe. And that leaves us with a pretty exciting question. What incredible discoveries are just around the corner, waiting to be made, all because the world finally learned to speak the same language of measurement?